Hello, we're going to do a lot of exponent and radical questions. So let's start off with this one. So we have a double square root. So we have a square root of 81. It's best. There's many ways to solve this question. The most easy way is we already know what the square root of 81 is. That is square root, and that is 81 is just 9. So square root of 81 on the inside is just 9, and the square root of 9 is just 3. Another way to solve it is we use the exponent rules, or not exponent rules, radicals. So square root is a 2 here. Any number is also just x to 1/2. So we can even do it like this. Square root 81 is inside 1/2. And then also a square root on the inside can express this 1/2. And on the outside is still 81, 1/2. And then you would use exponent rules. You multiply the inside, that's 1/4. If you know what 1/4, you can change that back into radical. The fourth root of 81 is 3. So you get the same thing. One is much harder, but if you know, like what if there's a case like we don't know the inside is 81, we don't know if it's a square, so like 54, then you would have to do something like this. But since it's easy, we know what the square root of 81 is, it's better to do this method, and you just get 3c is your answer. Okay, next we write the following as a product of prime factors. They already give us the first step. And then state whether the result is a perfect cube root over a perfect square root. So I'll walk you through what that means. Let's first do the first one. We have to prime factorize it. So what is something that we can divide 216 by? Well, I know since it's an even number, we can always divide it by 2. Well, you can also divide it by other numbers like 4 or 8. But I guess for start, we just divide it by 2. It's 108. This is a prime number, so we can stop there. 108 is also an even number, so we can divide that by 2 again. 54. 2. I should write it here instead. 54. This is prime, so we can keep going. 54 is an even number, divided by 2 again. That is 27. This isn't even, but I know that we can divide it by 3 and 9. This is prime, so we can stop there. And 9 is just 3 times 3. Now, if we're looking for perfect cube root or perfect square root, then we know that they're either going to be expressed as this, perfect cube root, or this, square root. You don't have to write the 2 there for square root. To find those, look for either groups of 2, 2s, or 3s or 2s. Make sure it's in order, 3s or 2s. So what do we have here? We have a group of 3 and another group of 3. So let's just try if this works out. So we have a group of 3. We're looking for groups of 3, so that's 2 times 2 times 2. That's 3 times 3 times 3. That is also same as 2 cubed and 3 cubed. There's different ways to do this. You can combine them together and then take the cube root. But I think it's better to do this. Since it's multiplication, we can split up the radical to get something like this. Since multiplication can split radical. And now these cancel out. These cancel out because it's a cube root of a cube, and it's a cube root of a cube as well for this one. So that would just be 2 times 3, which is 6. And since we get a whole number, since it all works out, it is since we found groups of 3, and you get a whole number at the end, you can even double check that the original number we were trying to find, and we cube root it, we get 6, which means it is a perfect cube root. Perfect cube root. Therefore, perfect cube root. Let's go with 525. Let's try that. Let's check if it's either a perfect cube root or perfect square root. So 525. Let's prime factorize it so we can work with those primes. So 525, I know that it's divisible by 5. So there's 5 at the end. And that you can divide that by 5. 5 is a prime number, we can stop here, and then there's 105. Also, you can divide by 5 again. 5 and 21. 5 is prime, so we can stop here. 21 you can split into 7 and 3. They're both prime, so we can stop. Now, look for either groups of 3s or 2s. Well, we have a group of 2. You can't form any other groups with these numbers, though. So, you can try to do square 5 squared times 7 times 3, but that's all we can go with. 5 squared, split this up, 7 times 3, that's just 21. And these cancel out, so that's 5 square root 21. This is not a whole number, which means it is neither a perfect cube or a perfect square, because we can't find groups of 3 also, so it's not a perfect cube. We found a group of 2, but they're not all groups of 2. So I think I should specify of either all groups of 3s or 2s. So it's neither a perfect cube or a perfect square, because this is not a whole number. And you can check on your calculator. If you take a square root of 525, you should get a decimal. And also you can even check cube root of 525, also a decimal. So it's neither. So therefore, neither. Okay, now let's move on. So simplify. Well, we have this is an entire radical, and these are all mixed. So what it means by simplify is turn it into mixed. Turn into mixed radical, which means we gotta prime factorize and pull out all the whole numbers out of the radical. So let's try to do that. 40. I know it's divisible by 4 and 10. Can break this up to 2 and 2, both primes, so we can stop there. 5 and 2, both primes, stop. Now, since the index here is 3, it's cube root, so we look for groups of 3. There's 1, 2, and 3 right there. So we can group that all up into 2 cubed times 5. There's a cube there. And so using properties, since it's multiplication, we can split them up. Multiplied by cube root 5. This cancels out. So that is 2 times the cube root of 5. That should be B. Okay, makes sense. Let's move on to this one. Simplify. Well, we can simplify the inside more. We can pull out some more whole numbers. And we should get one of these answers here. So that's what we need to simplify. So turn it into a mixed number, but it's not fully, or not, a mixed fraction, a mixed radical, I meant. We have to decompose that 80 more. So let's divide 80 up. We know that's 8 and 10, and 4 and 2, and then 2 and 2, all prime numbers now. 5 and 2, all prime numbers now. Now it's a square root, so we're looking for groups of 2. There's an invisible 2 here, that means square root. So that's a group of 2, and these two are a group of 2. To write that out, 2 squared for this group of 2 times another 2 squared for these groups of 2, and then times 5, and there's a 5 at the end of here. And then you would just use properties of radicals. Since they're all multiplied together, you can split them up. Radicals cancel here. This is square root of a square. Radicals cancel there as well. 5 times 2 times 2 times square root 5. Get this together, you get 20 square root 5. That should be D. Yep, should be D. Let's keep going here. Write as a complete radical. Now, writing as a complete radical is much easier than trying to write as a mixed radical, because you don't have to decompose the inside. Instead, it's like the reverse order. So what you want to do is, just like how we canceled out 2 square root 2 is equal to 2. The reverse for this 3 here, you want to put this 3 back inside. This 3 back inside is, you want to square root and then 3 squared. Usually these cancel out and you get 3. But now we want to do the opposite, the reverse. See, so just 3 square root, 3 squared square root 3. So, and then you can put them back together using properties of radicals, since they're all multiplied together. 3 squared times 2. Notice how if we reverse it, we would get this when we split up the 2 radicals. So now, just simplify it. That's just 9 times 2. That's just square root of 18. Should be D. Okay? Let's move on. So now let's write as a complete radical again. Now it's a cube root. To put it inside a cube root, you gotta first cube root it, cube it. Notice that these cancel usually, and you get 4. But now we're doing the reverse process. We use cube root and cube it. And now you can put it inside now. They're both the same. Cube root inside the bigger 4 cubed times 2. Usually if you do the reverse process, you would split them up because they're both being multiplied. And then you would get 4, that is 81. 64 I meant, 64. Yeah, 64. And then times 2 should be 128. Now it's asking for what's in this blank. So what's in the blank is 128. That's what we got. See? Okay, and next, let's go to right. Which whole number is the closest to square root of 75? Well, we don't know what square root of 75 is, but I do know if you write it as a mixed number, we have a whole number in front of the mixed number, you see? So it's easier to know which is the closest if we turn it into a mixed radical element, or mixed radical. So let's turn to mixed radical first. Because we know there's going to be a whole number in front of the mixed radical, in front of the radicals. So square root of 75, that's 5 and 15. And this is a prime number, so we can stop there, and then 5 and 3. Since it's a square root, so there's 2. Look for groups of 2. And that will be 5 squared. There's 2 groups here. There's a group of 2 here. And then times 3. We can split them up because they're both being multiplied using properties of radicals. These cancel out because it's square root of a square, so that's 5 square root 3. Now, you can use a calculator for this. And you should get 5 times the square root 3, put that into your calculator. You should get 8.6602 ... And what is that closest to here? That's closest to 9 if we round up to 9. So the answer is C. Okay. Next, we have in the expression, the base is. So the base is whatever the base is of an exponent. So that can be 4. So what's the base here? Well, we know that it's only going to be the base of what's under it. So negative 5x 4. It would just be x is the base. Now, there can be a lot of confusion with this question. Some could think that this is the base, but if it is the base, it would be bracketed. So to show that this 4 is to the power, this negative 5x is to the power 4 of the whole thing. But we only have negative 5x to the power 4. The base is just what's under it. It's just going to be x. If it is negative 5x or negative 5, it would be bracketed that way to show that it is to the power 4. But since only x is under it, x is the base, which means that it's C. Okay? That makes sense? Now this is, we use exponents. So I think we're done with radicals, we're doing exponents now. X to the 3 to the 4 times 3 to the 2 times 3 to the 7. First, to use exponent rules, you have to make sure they're all the same base. Make sure all same base. Okay? And they are, so that's a good. We can move on to use exponent rules. Exponent rules or exponent laws, for this case, multiplication for the exponent law for that is, as long as they're all the same base, we just add the exponents. So that is just equal to 3, 4 plus 2 plus 7. Okay, that makes sense? And that is just equal to 3 to the 13. Should be A. Next, we're doing division. Again, check if they are the same base. Base of 8, they're the same base. For division, we subtract. The exponent rule or exponent law is we subtract the exponents. You can rewrite this as a to the power 24 divided by a to the power 4. You subtract the two exponents together. Should get a to the 20. That is E. You can move on. Next, there's different ways to do this. Some teachers prefer to just simply use the exponent rule to multiply a power of a power. So if you see a power up to another power, then you just multiply those two powers together, get 7 to the 7. Or you can do 7 power 4. This means 7 cubed multiplied by itself 4 times, or 7 cubed multiplied 4 times like this by itself. Gets you the same thing. And then you do the multiplication exponent rule. You add up all the exponents together. Oh, sorry, yeah, this is supposed to be multiplication. So 3 times 4 is 12. And here you add up all the exponents together, you get 12. Okay, that makes sense. That's C. So yeah, if you're doing the power of a power rule for exponents, you multiply two exponents together. 2 times 4 is 12. Or you can do it this way, which is 3 cubed multiplied by itself 4 times. And then you do a multiplication rule, add up all the exponents, and you should get 7 to the 12, same answer. Next, rewrite using positive exponents. So every time you see a negative, or you want to switch, if it's positive, if you want to move it to negative, but here we're trying to turn to positive, you would have to do a reciprocate. So you have to reciprocate whatever the base is. So let's just say, for another example, this was like 3x, and then there's like a 5 here, and then this is negative 2. You would reciprocate whatever the term or base that this negative 2 is attached to. Say this is like 1 at the bottom. Then you would reciprocate 5, 3x, and then this is now positive, so you moved it to the bottom. Okay, that's just a separate example. So in this easier case, but this is just a slightly more general case, this 5 to negative 2, basically over 1, you reciprocate it to the bottom, 1 over 5 squared, same thing, 1 over 25. Make sense? This is A. Alright. Now, let's do this one. 2 to the power negative 1 plus 5 to the power negative 1. Can we add the exponents together? Well, clearly not, because that only works for multiplication, and the bases are different. So you would actually have to do look at them individually. So remember how we would move to turn this into positive? How we would to the exponent to positive? You would reciprocate them. So this 2 to the power negative 1 is just 2 power 1. That's just 2. And then you would do 5 power negative 1. the same as moving it to the other side, reciprocate, so that the 5 to the power 1 is now on the bottom. It's now positive now. And that's just the same as 1 over 5. And then, if you remember how to add fractions together, make sure they're both the same common denominator. Multiply this by 2, multiply this by 2, multiply this by 5, top and bottom. So now they're both the same common denominator. 5 plus 2 should get 7 over 10. That should be D. Okay? Rewrite with positive exponents. Remember that same rule that we had? You only want to move the one that the power is attached to. This negative 3 is attached to this 5. So you only want to move that one down. So that will be, there's a 1 left behind. And then 4 to the 7 times the 5 to the 3 is now moved to the bottom with a positive exponent now. And you should get E. Next, this is a slightly confusing, but there's many ways to do it. 5 to the 3, negative 2. You can first off by distributing this 2, since it's either multiplication or division inside, you're allowed to distribute, since it's only multiplication or division that's inside. That's 4 power negative 2, 3 power negative 2. Now, since they're both negative, it's much nicer to switch them around. Whatever this negative 2 is attached to this 4, you bring it down. Whatever this negative 2 is attached to this 3, you bring it up. So they just switch places. Now it's positive 3 squared at the top, and 4, and then positive 2. So that's 4 squared at the bottom. And then you can do 9, 16 is your answer. That's D. Okay, makes sense. Next, let's do this. Now, there's different ways of doing this, of course. I think it's best if I just change the width of this pen smaller. Okay. Power 3. Since it is all, well, this power 3 is all, the base is all this, power 3, since there's brackets. And since there's only multiplication or division that's inside, we are allowed to distribute. Distribute to all of these terms and values, variables. So 2 cubed is 8. I'll write it in full. X, and then remember power over power, 4 to the power negative 3. So that's, you just multiply them. That's the exponent rule. So that's 12. And 5 times 3 is 15. And then we can simplify it further to get 8. It's 12, y 15. Now there is another way to do this, of course. Since it's power 3, it's just multiplying whatever is inside as the base 3 times. So you can do it alternatively like this. It's a lot longer though. This, and this 3 times. And you don't do FOIL here because it's only multiplication between the terms. It's all multiplication. You can just drop the brackets. And then you would multiply it all out, multiply all the x's, multiply all the 2's, multiply all the y's, and you should get the same answer. 8x12, y15. Okay? Next, we're going to do this one. So it's probably the hardest one that involves exponent rules. So let's just change this around. Negative 3a cubed b squared. Just going to rewrite it for myself. And there are many, many different ways to go at this. Now, you may think that, oh, we can just subtract 3 and 2. They're not the same base, though. And there's a 3 here, which could be complicated. Not the same base. So it's best if we just do the exponent rule for powers. Distribute that. Distribute this. So negative 3 cubed. Let's take a side step here. Negative 3 cubed. Now, what's the base? The base is just 3. If the negative is included, it would have to be like this to include that negative. The base is whatever the exponent is, whatever is under the exponent, and that is just 3. So it's better to do this way, to have the brackets here, to show that it's power of 3, only attached to the 3 and not negative. So doing it that way, we get negative, whatever is inside. 3 cubed is just 27. So we should get negative 27 for that. So yeah, this is a small side step just to let you know. Negative 27. A 3 times 3 is 9. B 2 times 3 is 6. Now we do the bottom. 3 is not unaffected. A squared, because A 1 times 2, so 1 here. And B 4 times 2 is 8. Now we're not fully done yet because we do have some simplification we gotta do. Negative 27, look at the numbers. Negative 27 divided by 3 is negative 9. And then we look at the other variables, make sure they're all the same base. Looking only at the same base, A, 9, A, 2. Subtracting those exponents because of exponent rules of division, that gives you A to the power 7. Okay? And now, there's 6 minus 8. That gives you a negative number, negative 2. I'll write it down in here. 6 minus 8 is negative 2. So we want to bring this negative 2 down to make sure it's positive. Most likely they'll have you put it in positive exponents anyway. So that's b squared. That should give you your final answer, B, for this question. Okay? Make sense? Now I threw this in just to make sure we don't get anything confusing. So would it be okay to distribute this 4 here? Well, it would not, because not only is there not the same base, but we can only distribute exponents when the inside of these brackets are either only distribute if only what's inside the brackets are multiplication or division. If inside is multiplication or division. So we cannot distribute. So we'd have to, well, in this case, it's easy. What's 2 times 2 plus 3, that's 5. Power 4, 5 to the power 4 is just 625. A side step would probably be to say we have 2x, so now it's a polynomial inside, and it's squared. Well, you still can't distribute it because it's addition. There's an addition there. You can only distribute the exponent if the inside is all multiplication or division. So probably put all. And the way you do this is you just remember squared means you multiply by itself 2 times, and then you would FOIL it out. That's the proper way to do this question. Okay, that's just a little side step just to clear some things up. Question 70, so 8 to the power 3/5, and you want to put into radical form, which means there has to be a square root or a radical in your answer. So basically, what's underneath is the index of the radical. What's on top, since it's on top, I usually think of high power. And what's in the bottom, I usually think of root. So that helps me understand what's happening. 8 to the power of 3, and root, what's at the bottom, 5. Okay, does that make sense? So that should be D. Next, write in explanation form. So it should be, what it means by exponential form, there's a base and there's an exponent. So let's say whatever, 3 or whatever. So we just redo the reverse process of what we did here. So let's go back to this, right? And let's write it down for myself. This is the power of the whatever number that's in the middle. Power. And then this is the root, which is at the bottom. Root. So we can convert that back. 7 power of 2 over 5, the root. And this is the power. Does that make sense? That should give you B. We're almost done. Now evaluate, which just means calculate in most contexts. So 16 power of negative 3 over 2, 3 over 4. There's many different steps to do this. I don't like working with negative. So whatever the base is, we take that whole base, move it to the reciprocated. So that just gives you negative, oh yeah, that just gives you 16 at the bottom. And now it's positive 3 over 4. We have to evaluate it though. So much better to evaluate it when it's a form of a radical. So we know that this is the power, 16 to the power 3. And this is the root. You can just put this thing into a calculator, and then you would divide 1 by whatever you get here. And you should get an answer. It should be either a decimal or a whole number. But you should get 1 over 8. Just double check on my own that this is correct. You should get 1 over 8. Yes, that's correct. 1 over 8. And that should be good. So whoever needs this video, and wish you well on your final exams. See ya. God bless.